Hi guys, welcome back. Today I'm going to be looking at ballistics calculators. So they're something that you use in long range shooting to make hits at extended ranges. You know, it's easy to shoot things when all you've got to do is point the reticle at them and pull the trigger, but when you're talking about making hits at 1,000 to 2,000 yards, then there's quite a lot of mathematics involved, and ballistics calculators will do all that for you. But they are not an easy solution by any means, because you still have to input all the correct data in order to get the correct data back out of them. And that's the main mistake people tend to make with these things, that they cannot be bothered to ascertain the correct data fields that they input. You know, things like muzzle velocity, and they take guesses and then they put all that data in, and once it comes out the other side, it's completely flawed and they end up missing targets. So I'm going to do a bit of a overview using the Applied Ballistics Analytics software. We're going to take a look through that, look at all the different data fields, explain exactly what needs to be input there and why it's important, show in some cases how that data input will affect your output and why you would end up missing the target if you don't get that correct. And we'll just go through each part, break it down, because it's not a simple thing. You know, people sort of just jump on the calculators and think that they're going to be a really simplistic solution, and that's why long range targets are really difficult to hit, not least because you have to be able to read the wind and judge some environmentals, but also because you have to have a fairly competent level of data input and understanding it to be able to utilize that properly. So without further ado, we'll go over to the screen recording of the software, and you'll just hear me talking about it, and hopefully you'll be able to follow along. Thanks a lot. Thank you for watching. I hope you enjoy the video.
Okay guys, so we're taking a look at the Applied Ballistics Analytics software here. That's my ballistic calculator of choice. They do that in a mobile format as well, I think on Android and iPhone. But a lot of the stuff I'm going to talk about here is applicable to whichever ballistics software you're using. A lot of these inputs and outputs are going to be exactly the same, so it should give you a basic idea of what you can and can't do on these things. So the whole point of what we're doing here is to give us outputs which are accurate and allow us to make hits on target at long range, which you would find it very hard to calculate on paper. It is theoretically possible, but it's incredibly hard work and quite long-winded. This does it all for you, but don't, for example, think that this is an easy thing to do. Like I've mentioned in the preamble, if you put a load of garbage into this, it will spit garbage back out, and I hear people complain about the calculators they use, and a lot of the time the fault is actually with the input data. So we'll start off here in the top left corner. We can see we've got bullet properties, and then here we have ballistic coefficient. So that allows you to input a G1 or a G7 coefficient. Now, for those that don't fully understand what those mean, they are basically standardized shapes of projectiles. So G1 is an older standardized shape, and it doesn't have a boat tail. It looks a bit like an old artillery round, if you like. And then the G7 is what's nearest to what we would call a hollow point boat tail or an open tip match bullet nowadays. So if you're using one of the G numbers, I would tend to use the G7 unless you're using a specific projectile that looks like a G1 shape. But most people are going to use the G7. However, do bear in mind that part and parcel of these pieces of software, and especially with the Applied Ballistics guys, is that they actually have worked out a bunch of custom drag curves specific to each bullet. So if we hit this bullet database here, you can see you can select all different kinds of projectiles there. It's got your G1 in this tab, your G7s in this tab, and then if we go over here to the far right, we have Applied Ballistics custom drag curves. And this is where the software, they've spent a lot of time and a lot of money getting these custom drag curves for you. They've shot thousands and thousands of rounds, gathered the real world data from those rounds, and then created customized drag curves. Because the G numbers are basically using your ballistic coefficient in reference to that standardized projectile shape, and they're going to create a trajectory based off those calculations. With the Applied Ballistics custom drag curves, it's using real world trajectories that have been gathered with that exact bullet. So it's going to be a lot more precise than using the G numbers. They may not have your projectile listed, so it's not always possible to use custom drag curves. But if you're just getting into shooting, or you're going to have a projectile change to the shooting that you're doing, then my suggestion would be whatever ballistics program you're using, if you've got custom drag curves listed on it, then find a projectile on there that has a drag curve listed and select that projectile for your shooting, and things will be a lot easier. So we've got the Norma match in 308 168 grain there. We'll select that. Okay, we've got it set as our custom drag curve. That's what we want to use. It just says you're selecting a new bullet. You'll overwrite. Yes, you want to proceed. So we do. There you can see its input data here, the 168 grain, 308 for bullet diameter, and your bullet length as well, 1.203 inches. You can change the input data here in units. You can change input and output, mixed English metric, and you can go inches, mils and MOA depending on which inputs and outputs you wish. We'll leave it like that for the minute. Then we move down to gun scope properties. So this is where a lot of people start making a mess of the input data. Muzzle velocity is one of the most important factors here that we're going to input, and a lot of people fudge this because they don't have a chronograph, they've never measured their muzzle velocity, and they're going to take a guess. They're maybe going to look at the ammunition packaging that they've purchased, or they're going to look at some load data and see what the basic outputs from the load data are in terms of feet per second for muzzle velocity, and they're just going to stick that figure in there. Now that figure is going to be most likely wildly different to what you're actually going to get out of your specific rifle. And even if your friend has a rifle made by the same manufacturer with the same barrel length, chances are there's going to be a difference in muzzle velocity, because he might have put 2,000 rounds through his gun. Your gun might be brand new. There's going to be a difference due to the gas flow through the bore. The amount of erosion is making the difference there. And one's going to be shooting a lot faster than the other. I'll say a lot, but certainly enough to make a difference in terms of what we're going to input here. Rifle manufacturers will use different barrels as well. They might have 4 or 5 different barrels that they buy from, different companies. So your friend's rifle might have a Bartlein barrel on it, and you've bought a rifle from the same manufacturer a couple of years later, and it might have a Lothar Walther barrel on it. There's just there's no way of accurately predicting this muzzle velocity without actually getting a decent chronograph out and getting it yourself, and that's going to change based on the temperature as well. So it does have this option here, use table. Instead of just putting in your singular muzzle velocity there, you can hit use table, and then if you go down to MV temp table, that here gives you temperature on one side, muzzle velocity on the other. So if you've got some data where you've recorded the temperature on the day that you were shooting and the muzzle velocity as well, you can add them starting from highest temperature and working down to lowest, and that will tell the software that you've got a temperature sensitivity with your propellant, which is going to affect muzzle velocity. Very hot day, likely the muzzle velocity is going to be higher. Very cold day, likely it's going to be lower. There are some slight caveats to that. 9mm is one that is a very odd situation that you often find with 9mm, that actually when it's really cold, the muzzle velocity goes up, and when it's really hot, it goes down. And that's partially to do with the fact that there's very little volume in the case. It's a small case, straight walled, and the freezing cold temperature basically affects the case's ability to fire form rapidly, and then a really cold case which doesn't fire form as rapidly produces a higher muzzle velocity. But for most rifle calibers, you're going to find heat increases muzzle velocity. So we'll close that down. Zero range. Now these all come preset, and you want to change this to exactly the range that you use to zero your rifle. Make sure that you get this correct as well. A lot of people guess that. Don't guess it. You can mark it out. Make sure you've checked with the range that it's exact, or get an LRF and laze it with that. Use a decent LRF, guys, and we'll get to that in a minute as well when we look at range to target up here, that it's really important to use a decent LRF, because if you don't get these correct, the data that you spit out will be wrong and you won't be hitting your target. So our zero range is set at 100 yards. That's what I normally zero a rifle at. If you've got different zero, it doesn't matter, just make sure it's correct. Sight height is the height of your scope above the bore. So it would be the center of the bore to the center of your scope, and you can easily measure that. I've measured mine with some vernier calipers, but just to give you an idea, it does make a difference. We can see there at 1,000 yards, we've got 12.74 mils of elevation at 1.50 inches sight height. If we change that to 2 inches, so this is the sort of thing people are guessing, and you can see we changed to 12.65. That might not seem like a huge deal, but if you're shooting at more extreme ranges, that will become more and more noticeable. And the other issue is it might produce stacking tolerances, which is where you might have a little bit of an error here, and then you might have a little bit of an error on your muzzle velocity, and then you might have a little bit of an error on things like your temperature for the day, pressure, etc. And when you stack all those things together, you end up with quite a large error. So that's why it's important to get each of these, correct. So we'll keep that at 2 inches, but do measure yours. Make sure that you've input that correctly. Then we have twist rate here. So we're using a 308. The likelihood is it's something like 1 in 10 or 1 in 12. But again, check with the manufacturer. You should have a manual with the rifle that will tell you your twist rate. And this can make a difference in terms of projectile stability. So if you're looking to keep projectiles stable that are heavy in class, in caliber class, you might want to be shooting a 180 grain projectile in 308 or a 200 grain projectile in 308, for example, and they're probably not going to stabilize too well at a 1 in 12 or a 1 in 10 even. So you might want to go even tighter when you buy a rifle if you're specifically wanting to shoot very, very heavy projectiles in class. And it does help us, this software, because over here in the stability factor on the outputs, it actually tells us a stability factor for our projectile, tells us if it's stable in that twist rate of barrel. So we can see here we've got a stability factor of 2. Now, a stability factor above 1.5 suggests that your projectile is being perfectly well stabilized and you're not going to see any loss in BC. If the projectile is not completely stable, you will see a loss in BC because of the yaw of that projectile. As it yaws, it's not as efficient in terms of being aerodynamic, I suppose would be the best way to explain it. Anything under 1.5 and you're going to start losing about 3% ballistic coefficient for each 0.1 you fall below. And then if you get an SG below 1, then that is not stable at all, and that is actually likely to tumble. So we can change the twist rate here just to give you an idea that if we, for example, had a 1 in 15 inch twist rate, that would give us a stability factor of 1.12. So in these atmospherics, it would just about be stable, but where you might run into problems, for example, is if we were to make some changes to this pressure, let's say we went up to 35, then we would see the stability factor drop below 1. Now we're likely to start seeing some tumbling of projectile keyholing at target, and it would be impossible to map the point of impact of that projectile, and in fact it would stop way short of the target because it would be tumbling. So it's important to buy a barrel that actually can stabilize the projectile you want. Most 308s are going to be a 1 in 10 if you buy a modern rifle. Some are even tighter than that, and as you can see, a 1 in 10 for a 168 grain gives us 2.53, which is more than adequate. There's no stability problems there whatsoever. Then we move up to target here. We've got range to target, which I discussed before. This is important. You're going to want to LRF that and make sure it's a very accurate value. I use the Steiner optic stuff. They're really, really good. Those guys make high precision, military grade laser rangefinders. They have them in very, very good binoculars. So you can basically use that and get a very, very accurate range to target. If you buy something off eBay that's like 300 quid, it's never going to be able to laser long target and give you any sort of range. And the ranges it does spit back at you are likely to be very inconsistent, and I would not even consider them unless you're like shooting in a field with an air gun or something and you just want some basic info for that, but certainly not for long range shooting. You do need to spend a good deal of money on a decent LRF. Heading you can actually get off your phone. You know, if you've got a map feature on there, you can get your heading to target. Inclination, we can either use information that's generated if you're lucky enough to have an LRF that's given you inclination to target, which a lot of them do. You can input that in there. You can also buy a little analog inclination dial that you put on the rifle itself. It just slots on a Picatinny rail if you've got a spare section, and that will give you an inclination reading as well. Some people use their phones. That's probably not the most accurate way of doing it, but you know, it can be done, and it can make a considerable difference. So if we put in an inclination there and we again look at 1,000 yards, 12.66 on elevation, we've changed our inclination. Now we're at 11.87. So quite a big difference if you get that messed up or forget to input it. Latitude to target, again, you can use a compass or map to sort out your latitude, and then target speed is referring to moving targets. Not something that most shooters are going to use, but if you're a tactical shooter or if you're shooting in some sort of competition that happens to have a moving target in it, you might find this useful. A lot of guys are going to leave that at naught, and then they're going to have their own dedicated moving target data that they're going to input on top of this stuff. So they might have some very basic stuff for a walking speed, running speed, certain vehicle speeds, and then they're going to input that after the fact. So I'm going to leave that at 0. Then you've got your environmentals. Again, this is stuff that people often fudge. So you've got your average wind speed, which can be really difficult because if you're using a Kestrel, for example, a lot of people use those anemometers to give you a wind speed. That's going to give you wind speed at firing point. That's not going to predict what the wind's doing right across the trajectory of that bullet and, you know, up until the target. And that whole thing is important because the wind's going to affect your projectile right through its trajectory, and you're going to have to use a bit of your own experience to kind of guess what the wind's doing. You can get a very good reading from a Kestrel at your point, but you're then going to have to make some sort of a guess as to the overall wind speed. Wind direction, again, that can be trickier than it sounds. It's obviously fairly easy to assess wind direction just by gauging it at firing point. But if, like me, you've shot in valleys and hills and different undulating terrain, the wind swirls around there, it moves like a fluid, and it will move around all these different undulations. So you can actually find wind direction changing throughout the trajectory, and that's something else you're going to have to use a bit of experience and decide for yourself, you know, how much those changes are going to affect what your input is on here. If you're just shooting across a completely flat range, you know, the classic gallery range, and you've got wind flags up, it's going to be a hell of a lot easier. Some of those ranges have flags dotted right the way down, so you can look at them and you can make a pretty clear assessment of what you might input on here. Temperature is pretty obvious, and that's again something that people just leave, you know, they don't bother updating it. You do need to update that, because that is going to affect your powder sensitivity, and that will also tie in with some of the inputs you've put in here. If you've bothered to do your temperature sensitivity for your propellant and how it affects muzzle velocity, then that's going to correlate over there as well. Pressure is an important one. A lot of people get this wrong. There's two types of pressure. Now, there's station pressure, which is the pressure at the exact point in time where you are, and that's what you need to input here. And then there's something called barometric pressure, and that will have a calculation done on it to basically give you pressure at sea level. So even if you're not standing at sea level, the barometric pressure will be calculated for sea level, and you do not want to input the barometric pressure here. So if you're looking at a weather chart, you know, from the local news or whatever, and you're inputting that pressure, the likelihood is you're accidentally inputting barometric pressure instead. And as we've already seen, you know, changes to pressure do make a difference to the output data. Humidity does make a slight difference. It might be worth inputting if you're an extremely long range shooter, but the differences aren't massive, and give you an idea of how it would affect it. If we put in 40%, we're currently at 12.66 mils of elevation. If we went from 0 to 40%, we go to 12.62 mils of elevation. That's at 1,000 yards. So not a massive difference. If we bump it up to 80, it's still not going to make a huge difference. 12.59. So yeah, you know, if you start getting out to 2,000 yards plus, that is going to be worth taking a look at. But other than that, if you're within 1,000 yards, it's not going to make you miss the target on its own. But that does feed into the stacking tolerance issue that we spoke about before. So if you've got this variable wrong and a number of others as well, that's going to be a problem going forward, because then they're all going to affect your data and you are going to be off target. The software works out your density altitude for you. So that's not an input, that's actually an output field there. So don't waste your time trying to put something in there. Now we have our outputs on this table here. So it breaks down our elevation outputs into gravity drop, Coriolis drop, and aerodynamic jump. And then it gives us our elevation there. And that's giving us our elevation based on here, range to target. We've input 1,500 yards. But if we were to, let's keep it all at 1,000. So we're pretty simple on everything. Then we're back to this 12.59 figure here. Then it's going to discuss windage in this next part. It gives you your wind drift, Coriolis drift, and spin drift. Spin drift you can turn on and off. I would keep it on. The Coriolis, in case you didn't know, is about the rotation of the Earth. So that does have an effect at if you're shooting at very long ranges, and it just breaks that effect down on each of these just to tell you how much of an effect it's actually having overall, which obviously isn't much because the Earth isn't moving a huge amount while you're shooting. The projectile isn't in the air long enough for that to have a huge effect, but the further you shoot, the more effect it's going to have. Then below here we've got our max ordinate, which is the maximum height that projectile is going to reach. That's giving out in inches, 169.14, our max ordinate range, which is basically at which range is that maximum height reached. So at 587 yards, you know that you're going to reach this height here. That's going to be important for people like snipers that are doing loophole shooting, and they want to know, you know, if they're going to make it through objects in front of the target and then to the target after that. They don't want to hit objects before they actually hit the target. So that's going to give them some good information. And also you might be limited on height, you know, by obstructions and stuff anyway, even for hunters and stuff. So that's going to give you enough information to make sure you can make a clear shot without damaging anything. And then, as discussed, we've got our stability factor there. Then in this table here, we've got our output settings. Now you can go into settings, select your start range, your stop range, and the increments that it measures in. So you could set your increments at 10 yards, 100 yards, whatever you want. We've currently got them set at 100. And then it's going to give you time of flight, your Mach number, which is basically if you're breaking the sound barrier or not. So that tells you when the projectile starts to go subsonic, which is an important piece of information. That's where you might want to break these numbers down, because you can see that we're subsonic somewhere between 8 and 900, but it's not exactly clear. So if we were to go into the settings and change those increments, let's say to 25 yards, then it's going to break it down even further. Then if we scan down here, we should now be able to see a little bit clearer exactly when it goes subsonic. So it's between 850 and 875. Knock it back to 100 just for ease of viewing. Velocity just shows you obviously the velocity decaying as you increase the range, and again you can use this to ascertain when you go subsonic. So we know we were between these two figures here. Energy, that's energy on target in foot-pounds. So if you were shooting at something that was 1,000 yards away, you can see there that you're still maintaining 351 foot-pounds of energy. If you're a hunter, that may be important to you. If you're a tactical shooter, that may be important to you. If you are, you know, a target shooter, it probably means next to nothing, because you just care about putting a hole through a piece of paper. You're not too bothered about how hard you're hitting it. Elevation value, you can either output that in mils or MOA. We've got it set in mils at the moment, but as you saw earlier, you can change your units there, output, set that for mils or MOA, but that's fairly self-explanatory. Windage, again in mils, and that's going to give you either this plus value or a minus value. So if we input the wind direction to 3 o'clock, you will see that then these windage values change with this minus value here, telling you whether you either need to adjust to the left or to the right. So we'll just change that back. And then lastly, we have our drop in inches. So that's probably not too much of a concern for you, because we already know that we've got our elevation here in mils. That's going to be the main point of interest for people. So that's the basics of your ballistic calculator, and there are a couple of other settings in here. You have this muzzle velocity calibration. So if you shoot and any of your data is out, and that might happen if you've got your G1 inputs and, you know, it's not being completely accurate, we know what the drop is based on what we've dialed in on our elevation of our scope, and it isn't matching up with the elevation here. And at 1,000 we're actually dialing in 11.5 mils, for example. Then you can calculate the MV. That will give you a different muzzle velocity. So that might tell you that the reason that this calculation was off is because you've actually got the wrong muzzle velocity input. If you're 100% sure of that muzzle velocity, then that is probably not what is wrong and you want to check all your other data. But if you are not 100% sure of it, then that will update your muzzle velocity. You can choose to use that muzzle velocity and it will actually overwrite here. That might be something that happens if you haven't taken into account temperature, for example. Now, it also gives you the ability to calculate for what they call drop scale factor. The drop scale factor is used to refine ballistic solution in subsonic flight. So by firing rounds at long range and noting the true drop, a drop scale factor is computed, and click Use DSF populates the drop scale factor value and Mach number into the View DSF table. So we've done so here. If you needed to do this, calculate DSF, it's changed the Mach at range, so it's just adjusting the velocity at range, and that's to do with when the projectile starts to go subsonic. There will be some differences maybe there, and this will allow you to update that slightly and just calculate a little bit of a more accurate trajectory. If you're using the custom drag coefficients, this shouldn't be necessary. Then we have our advanced settings here. So if we open those up, it will allow you to put in your conditions, weather conditions for when you zeroed the system. That's worth doing. So if you zeroed at a specific temperature, specific pressure and humidity, you can input those. That will enable the software to calculate the difference between the environmentals that you've put in on the day of your shooting versus your zero temperature and zero pressure and humidity here. And then below that, with gun scope advanced properties, this allows you to slightly change any errors in the scope. So you might find if you do a target test and you've maybe cheaped out a little bit on an optic, and even some of the higher end optics you might find this with, that they can be slightly out, you know, that you could dial in what you think is 30 mils and it's actually 29.5 mils in reality, because the adjustments on it are just slightly out, and the more adjustment you make, the more that error will show. It's very likely that if you've spent a lot of money on the scope, that's not going to be such an issue. Like I say, I use a lot of the Steiner optics. I've never had any issue with them being off, and they do very, very extensive testing on their optics to make sure that what you dial in is what you get. And, you know, there are some other optics I've used that have been on the cheaper side of things when I started off shooting many, many years ago. And also probably because it was many years ago, the optic manufacturers weren't quite as proficient as they are now. But you did used to see a little bit of difference in terms of the elevation or windage you were dialing compared to what it actually was at the end of the day. So if you have a scope that's got any of those errors, you can input the errors there, and that will take into account those errors for the calculations below. So there we have it. That should give you a very good drop table and windage table for what you're shooting. And you can then, if you want, export that range card on that function there. So that will basically export this data below down here, and you can save that for a later date should you be shooting at the same place and it happens to be pretty much the same conditions. So we've got all our data mapped out. We can then get into this next tab, the Weapons Employment Zone, WES. Now, this is quite an interesting one because you can use this to tailor certain aspects, and you can see where your errors are, you know, what's causing you to miss the target. So it comes pre-filled, and these are variables from one of the long-range shooting books that it's pre-filled with, of like standardized variables. And I think this is standardized variables for a fairly proficient shooter. So it's basically suggesting that there's a number of errors that we're making in the data that we're putting in. So if we're estimating wind, we've got an error of plus or minus 0.5 miles an hour. That's actually really difficult. Even if you run in a Kestrel, like I said, over that long trajectory, you've still got to work out, you know, the average speed of that wind over the trajectory. So it's very likely that you're going to be out on here, and most shooters are going to be out by a lot more than that. You're probably looking more at about 3 miles an hour, but we'll keep it at 0.5 for now. Oh, not 30.5. So return that to baseline. Temperature is plus or minus 1 degree Fahrenheit, which again is quite likely. Pressure is, you know, plus or minus 0.05, and humidity plus or minus 5%. Those are likely to fluctuate throughout the day, and they're not going to make a massive difference. Then we've got muzzle velocity. This is a big one. It makes a huge difference to your hit probability, and this is something, again, that people tend to overestimate. Most people think, oh, I don't have any fluctuation in muzzle velocity. So this is asking you to, if you get an SD over, say, 10 rounds of, you know, 5, then it's basically asking you to input that SD there. And that's a really tidy muzzle velocity deviation. You know, if that's what you're getting, then fantastic. Anything in single digits, if you're measuring in feet per second, is very, very good ammunition indeed. And I hear a lot of people say, oh, I get single digits, and I look at what they've done with the chronograph and they've measured like 2 rounds. Yeah, we can all handpick a couple of rounds and say we've got a single digit SD. But if you're shooting 20, 30 rounds through that thing, that's going to give you a much clearer picture. If you're a very proficient hand loader, you're going to be in single digits. If you're buying pretty standard or crappy factory ammunition, it's going to be huge, and we'll see how it affects it in a second. If you are buying really, really good ammunition like Norma, Swiss P, then you're going to be seeing some single digit stuff, no doubt. RWS as well. I mean, RWS, even some of their mill standard stuff is, I've seen it produce single digits, so it's pretty cool. Range estimation, again, plus or minus 1 meter, and that's going to come down to how good your LRF is, or are you just estimating it with eye? Because if you are, you might be plus or minus 20 meters. You know, that could be a huge difference on that one. Inclination, again, if you're estimating it, you might be way off. If you're using something like a decent LRF that's giving you inclination, you're probably bang on the money. And then your heading, again, if you're estimating that, or your latitude just by eyeing it or whatever, then they're going to be off as well. Then it allows you to put in your range to target, your system's precision. This is something that a lot of people get badly wrong. You know, if you've got a rifle that once shot 3 rounds at half minute of angle and you call that a half minute system, you're utterly wrong. You know, if you've shot hundreds of groups with that thing, let's say you shot 100 5-round groups, and the average of all those groups, when you look at them as a whole, was 1.2 minute of angle, then you've got a 1.2 minute of angle system, and that's what you would input here. You don't handpick your absolute best group that you've ever shot in the world, because even a 3 MOA rifle will accidentally group at half minute one day if you shoot enough groups with it. It's just that the law of averages, you know, that they're just as likely to disperse outwards away from each other as they are to land closer to one another, and it's just a matter of time when that happens. So you've got to put in an honest variable there. I've selected an IPSC target here, which is your standard figure 11. If you select this IPSC, it doesn't actually matter what these two variables have here, but they come into play if you were to select rectangle, circle, then you would input the size of that. So if we use these standard variables, and this is based on all the ballistic information that we already put in here, so with our Norma 168 grain bullet, so we'll input that above just so we know what we're talking about, Norma 168, and that way if you save it, it will save this name on here as well, and you will remember what you were doing. And then we hit calculate. You can see here range to target and then your probability of hit. So you're at 100% all the way just up to over 600, And then as we start to drop away, just after 600, our percentage starts to decrease. And when we get to around 850, we're actually going down to about 90% hit probability. And there's a number of different outputs you can use this thing for. So shot simulation is always quite interesting. That simulates 1,000 shots with all the variables that we've input. And you can see at our range of 914 meters, which is 1,000 yards, we've got a hit probability of 86%. And we can see that we're mostly missing to each side. That will be because of this wind variable here. So let's say we were absolutely bang on the money with wind. We didn't make any windage error at all. Then that tidies that right up. We've just got a couple of misses. But other than that, we're at a 96.6% hit probability at 914 meters or 1,000 yards. But that tells us that wind is probably one of the biggest problems here. And one of the mistakes people make is looking at that. If you then said, okay, I'm going to buy a new rifle, and you bought a 0.75 minute rifle instead of 1, actually that hasn't really done much for your issue. And even if you bought a half-minute rifle, which is a pretty decent rifle, it's tidied it up a bit, it's brought our hit probability up, but we're still making a considerable amount of misses to either side. So buying a very expensive rifle doesn't eradicate the windage problem at all. And we look at some other reasons that people might make misses on target, and that is because their muzzle velocity on their substandard ammunition is way off the mark. So if we stick that up at 20 FPS, which is very, very likely for standard factory ammunition, then we now see that we're making lots of misses above and below target as well. That's because of that muzzle velocity variation. If we tidied up that wind and said, okay, we're perfect at predicting wind, and we tighten that up, you can see that the muzzle velocity variation is actually causing that vertical stringing up and down target, and that's why you're missing the target. Part of that will be through range estimation. So if you bought the most cutting edge laser rangefinder known to man, you could tidy that up a tiny bit. It's just brought it up like a percentage, but actually we're still missing a lot below and above the target, and that is because of our huge muzzle velocity variation there. And if we were some sort of elite reloaders and we brought that down to 1 FPS, now we can see we've tightened that right up and we haven't actually missed the target at all. We've got 100% hit probability. So it also gives you here your wind effect. So that tells us our probability of hit down here, and then wind error in miles per hour. If we had a wind error of say 1 mile per hour plus or minus 1, it's actually still going to give us a 100% hit probability. The problems start coming in at just below 2 miles an hour. Anything more than that, and when we start to have plus or minus 8 or 9 miles an hour, we're right down to 10% hit probability there. So that gives you a good idea on how much the wind can affect what you're going to actually end up hitting. And then our vertical uncertainty tells us that in this case, our rifle is actually the biggest problem. So if we were to bring that down to 0.25 MOA, that would in effect drop the rifle out of that equation, because now that's dropped into third place. And the biggest problem now we've got is fluctuations in pressure. But let's be realistic about this. I'll just knock this data back. So if we've got, let's say, plus or minus 1 mile an hour for wind, let's say we've got a 0.75 minute of angle capable rifle system, and we've got a muzzle velocity of plus or minus 10 FPS, which is again still pretty good ammo. And then we use this chart. This chart's really, really valuable because it literally tells you where to spend your money, and there's no doubt about it, the biggest uncertainty that it gives us is muzzle velocity. You know, if you've got pretty standard ammo, and that's good standard ammunition, then your biggest problem with hitting the target is still muzzle velocity. Second is rifle. And don't forget, this is only vertical uncertainty. So the wind is not really featuring in vertical uncertainty very much because it's mainly causing problems to the left or right in the input scenarios that we've given. In the vertical uncertainty, the main problems are your muzzle velocity, followed by your rifle, followed by pressure deviation, followed by temperature deviation. And really, your muzzle velocity is the thing that you want to be changing there. Then we go down to horizontal uncertainty, and surprise, surprise, absolutely huge is the wind, and we're only at 1 mile an hour, but that is by far the biggest input there. So you can deal with that in a couple of different ways. You can either learn to be an amazing wind reader, so you could knock that down. You haven't made any wind error at all, which of course is highly unlikely because there's always going to be some wind error. So let's say 0.5, that's going to throw up wind as still being the biggest variable. But the other thing we could do is use some ammunition that was actually a little bit hotter. So instead of inputting that use table there, let's imagine that we can increase our FPS to 3000. This is why match grade shooters are going to be messing with their FPS values. We will see that wind value drop down. It hasn't dropped it a huge amount, but it's dropped it some. And that's because we've increased our muzzle velocity, which is obviously helping us fight that wind a little bit better. If we knock that out to 2000 yards, now we start to see why it becomes very, very difficult to hit targets at 1000 yards. That's 1000 simulated shots. We have got 4.5% on target over 1000 simulated shots, but that's because the 308 caliber is not particularly well suited to hitting 2000 yard targets. If we were to change our caliber over, let's say we started running 338, knock that down to something a little bit more sensible. Then we can go back to our weapons employment zone, and we can see here we had a shot simulation for 2000 yards with the 308. We've now changed to the 338, and we're now up to 20.8% hits on target. So you can definitely use this to get an idea of what kind of caliber you should be buying into. You know, if we change that to maybe the 375 Swiss P, then we would see that increase even more greatly. And at these type of ranges, that's when you would really have to get this stuff perfect. So you would want no error in wind. There you can see it's tidied that right up at this type of range. We're up to 36.1% already, and we don't want any error in temperature. That should tidy it up even further. Get the correct humidity value from shot to shot. Hasn't had a huge difference. The big one's going to be our muzzle velocity. So let's say, again, we're elite reloaders. We're just getting 1 FPS between shots. Now you can see with the 338, if you're really, really high level, and you also would have your inclination perfect as well, and your heading perfect. And even this one, you wouldn't have any variation in that either. Now you can see 87.2% at 1,829 meters, 2,000 yards. you're actually getting decent hit probability on there with the Swiss P 300 grain. So it's an excellent bit of software for telling you what to buy into, what not, where you should invest your money, which caliber you should invest in, which projectile choices to make. Should you buy a new rifle system, or should you use the old one and spend a lot more time on the range learning to read the wind? The answer to that is probably yes. But this gives you very, very good feedback on where you should put your money. Guys, I hope that's been of use to you, and you can take this away and input that into your own data and hopefully make some good hits on long range targets. Take care, and I'll speak to you all soon.